you to actually write an offline web application because it provides the spec for the browser actually like loading a page at all when you're offline. So what is an application cache? It consists of a web page, or alternatively a JavaScript web worker can also be a starting point for these. And that web page points to a manifest, which has a collection of static resources. Presumably, the static resources will be referred to in the page somewhere, possibly dynamically. And the cache also has some miscellaneous configuration information associated with it. Now, why would you want to bother with this at all? The answer is mainly cold start offline, although it's also perhaps of interest because of the fast startup times. If a resource is available from an application cache, it can be loaded immediately without accessing the network, so network latency is no longer an issue. And also, you get background updating for free. If you're dealing with a web application of much size at all, say a couple of megabytes, then pushing a new binary becomes a huge pain in the neck as your entire application is blocked while the new binary is downloaded. There have been a number of other workarounds for this, but application caches have the potential to replace these, perhaps. Speaking of replacing things, there's the issue of whether or not you can actually use this at all. In terms of desktop browsers, there's at least rudimentary support in Chrome 5, Firefox 3.5, Safari 4, and Opera 10.6. The spec is still undergoing changes, so I strongly advise you to test whatever you're trying to do if it's more than the absolute basic. Mobile browsers also notably have pretty good support for this across the board. At least all the current major browsers do. The Android browser started supporting application caches in 2.0, iPhone 2.1, Opera Mobile version 10.1, and WebOS version 2.0. Again, these are, they say that they support application cache, but there's not currently a test suite. And the spec is changing anyway. So getting into a bit more nuts and bolts for the hello world of application cache stuff. This is a simple HTML page. Notably, there's the manifest attribute in the opening HTML tag. And that is what points to our list of static resources I mentioned earlier. I've underlined some of the static resources in this page. There's a style sheet and a couple of images. One of those images is added dynamically via JavaScript, which is part of why you don't want to, just doing the browser's save a complete web page features often inadequate. The manifest is, at least to start with, very, very simple. You have to have the line cache manifest. You can have some comment text if you start the line with a pound sign. And blank lines are ignored, and then there's just the list of actual resources. Notably, the HTML page is implicitly added to the manifest, and this is non-optional. So, whatever my HTML page does not appear in this list, but it will be stored in the cache and be available offline. The manifest must also be served with this special MIME type, text/cache manifest. If it's not served with that exact MIME type, it will not be used, at least by a compliant browser. By default, the manifest must also be exhaustive. That is, you must have all of your static resources available, listed up front. You can't go back and add something to the application cache later without actually upgrading the whole thing. I'll come back to upgrades in a bit. There's also no expiration date, so it will live forever or until the browser throws it away or the user does clear all site data or something like that. There's also no support for redirects. If a resource redirects, it is assumed to have failed entirely, which is pretty obnoxious. And lastly, if it's an SSL/TLS page, then all of your resources must be from the same origin. You can't access like images on Google user content or blogger.com or gstatic.com. It all has to be on whatever domain name your application is actually running on. I'm sorry, actually just the same origin and all the usual policies that entails. So any questions so far about, like, this is just the bare basics. I'm going to get into more detail, but yes.
What is a failure condition?
Okay. So the question is, what's a failure condition? What happens is the page, if like the app cache manifest is served like with the wrong MIME type, then the cache is just not used or populated. And then and if the same goes for like any resource failures, like the cache is just ignored entirely. So it's actually an interesting debugging problem potentially. Some of the URL formats that are supported by the manifest include, there shouldn't be a leading / on the relative path, but you get the idea. It supports relative paths and absolute paths, as well as full URLs. And it also supports a special URL format that starts with a //. And that inherits the protocol of the host web page. So if the web page is HTTP, this is HTTP. If it's HTTPS, then it'll be HTTPS. Okay, so I mentioned cache updates. The process for this is actually fairly complicated, and here's an abbreviated version of the algorithm that the browser goes through. First of all, the cache is not loaded. This will occur when the onload event fires for the first time. And in the future, like if the cache is successfully created, and again, it'll be updates will occur every load of the page. Now, if the manifest is served with a success, like an OK response code, 2XX, or the bytes are different. So like a not changed response code does not trigger an update, and also just having the cache returning a 200 response code for the cache also does not trigger an update. What this means practically is that you need to make the bytes in the manifest change in some way if any of the resources in that manifest change. You can hack around it using like digests as comments in the manifest, a version number comment, something like that is some tricks that we've used. Then it will attempt to fetch each and every one of the resources in the manifest. It has no idea of just like some resources have changed but not others. It'll try all of them. Now, if they're all successful and they get like 2XX response codes for all of them, then the cache is marked as ready and will be used on the next page load. So you'll never like get a different image just because you like pulled it out of the DOM and put it back again and the cache expired in between. That can't happen. Now, this is where things start to get complicated. And we get into the more advanced uses of the application cache. You can actually include different sections in your manifest. The default one is the cache section. So if you include no section at all, then this is what things are assumed to be. And it's just a list of resources, as we saw before. There's also fallback entries, which are a list of URL prefixes and a resource that should be loaded if something matching that prefix is not available. And lastly, there's a network list. And this is a list of URL prefixes again, and anything in there is going to be fetched from the network all the time, even if you're offline or whatever. Okay, so we have an example here of a cache with all the sections. So the cache manifest line is still always required. And we have some comments, as well as one resource URL And we have a couple of fallback entries. We have a / that'll catch anything under this domain name and serve 404.html. And we have a slightly nicer version for images where we display this like not found JPEG, whatever that is. Then we go back into the default cache mode. So the URL images / puppy.jpg will be put into the cache explicitly. And then we have a couple of we have one whitelist prefix, and then we have this special character that I'll come back to. So anything under that starts with /rpc/ will always be fetched from the network. So you might imagine using that for, like XHRs back to your server or whatever. Okay, so I kind of hinted at how these are actually used, and to be a bit more rigorous about the actual effect of these different sections and what the browser does. If you're loading a resource in a page, like a style sheet or a script, or you're making an XHR or any of that type of stuff that you're already in an HTML page, then the following process is used. First, the browser looks at all of your network prefixes and checks to see if any of them are a prefix match. If they are, then it fetches it from the network and it doesn't look at the cache ever again. Next, it looks to see if there's an exact match on one of the cache lines. And for this purposes of this exact matching, only the fragment ID is ignored. Any query strings or other parts of the URL are actually considered. So you need to be careful about that. And like if you're using query strings, usually the ordering of your query string arguments doesn't matter, but it matters here for purposes of this match. It's very simple. Next, it looks to see if there's any fallback prefix matches. So at this point, it's already tried loading any network stuff. It's already checked to see if it just has an exact match in the cache. And now we're looking to see for any of these kind of not found sort of resources, which are a bit weird. And if that's the case, and if there's a prefix match, then it tries to fetch the resource from the network. And if that fails, and again, the definition of like success is very narrow here. You need like a 2xx response type. Then you load the cached resource that's included on the prefix match line. So like here, if you try to access the resource /foo, then 404.html would be loaded. And lastly, if you've made it through all of that and there's no more matches or explicit entries that match, and you have this asterisk as a list in your network section, then it will try to fetch it from the network. So this changes the default of you have to list everything beforehand or it'll just fail entirely, even if you're online. This changes it so that it will succeed while you're online but fail miserably when you're offline. And this matches across domains, which is part of the reason why it's an asterisk and not like just a / will only match everything under your domain. It won't match, whatever else. Okay, so some notes about this. The rules I just gave you only apply if it's a sub-resource of a page. That is, it's a script, an image, a style sheet, an XHTML, HTTP request, something like that. If it's a top-level navigation, like a frame or a new tab or a window, or if it's a web worker, then a cache has to be selected first. I'll go over that in a moment. Also notably, there's a WebKit bug that I've encountered in my work where fallback entries will be used even if a network whitelist prefix matches it. This was only fixed relatively recently, so it's going to affect Safari, all current versions of Safari and older versions of Chrome, including the stable one, and Android and iPhone. So This is kind of obnoxious if you were hoping to use fallback entries in combination with network entries. So with the bug fixed, then network entries or resources that match a network prefix never consult the cache. And lastly, it's worth noting that fallback prefixes must wait for the network to fail. If the browser knows that it's completely disconnected from the network, then that's pretty fast. If you're on a mobile device particularly, then it still has to make the request and get the 404 or whatever from the server. So it's potentially a significant latency depending on your conditions. So this is one of the more complicated and counterintuitive things about application caches is how they interact with top-level resources, like a frame. So first, the browser will try if the page that it's loading has a pointer, like if there's an existing app cache entry somewhere, and that app cache entry points to the manifest that it's an entry in. So if you're not just relying on implicit entries and you've explicitly listed foo.html in an app cache, and foo.html points to the same app cache, then it uses that. Next, it looks at all of its app caches and see if it's a match in some way, either for an explicit entry or for one of these prefix entries, for these prefix matching. So now all of your fallback and all of your network whitelist rules come into play, and it's not entirely clear what the order of precedence is. The specification just says something very vague, like try to show what the user most likely wants to see. So you want to try to avoid that case if possible. And yeah, so the next two, I'm sorry, I kind of covered steps 2 through 4 all in one go. But is it a cache entry, and then if it's a fallback prefix match? Notably, if it matches a fallback prefix, and that prefix gets loaded, I'm sorry, the resource associated with that prefix gets loaded, then the document will have, then the document will see its URL as being the URL of the failed resource. So your JavaScript can actually potentially interrogate your window.location and make some sort of decision based on that. So maybe you could say something more specific than your generic 404, or I don't know. So that's basically it for the HTML and plain text cache manifest. There's a very limited JavaScript API I'm going to talk about briefly. Any questions on what I've talked about so far? Yes.
You said the cache happens on the onload event?
So the question is, I asked if the caching, I said that the caching happens on the unloading event, and I said, and yes, it does. So the initial load of your page will proceed largely normally, and then only in the future will the app cache be consulted. And similarly, any update checks will by default, well, there's always an update check when the onload event fires. This JavaScript API allows you to check at other times. Any other questions? Remote sites? I don't see anyone. Okay. All right. So I mentioned that there's a very basic JavaScript API. You can't enumerate the listings in the app cache using it. You can't modify them, but you get some basic events and information. There's this ApplicationCache class, so to speak, and compliant browsers will have a ApplicationCache property that's lowercase a at the beginning, capital C in the middle, that you can interrogate. And you can also use self.applicationCache, and that's primarily useful when you're accessing this from a web worker. Web workers don't have the window object. this application cache object will have a status property, and that will contain the current state, which will be one of uncached, which means that it's not associated with any cache at all. Idle, which means that it is associated with a cache and there's no interesting stuff going on with it, so to speak. Checking, which means that the browser is currently attempting to fetch the manifest to see if there is an update. Downloading, which means that it's actually that it has found an update and it's actually trying to fetch the resources. There's this interesting event of update ready, which tells you that it has not only found an update, it has successfully downloaded everything, and like if the user hit refresh right now, they would get this new cache. And lastly, there's obsolete, which means that an update was found, and obsolete means that the manifest is gone in a 404 or a 410 response code sense. And if that occurs, then the browser is supposed to delete it, which is potentially inconvenient. It also has this JavaScript object also has two methods, neither of which take arguments. One is the update method, which just forces a check as if an onload event had occurred. And the other is this swap now method, which switches to so that any new resource requests that occur will fetch from the new application cache, the newly updated application cache, instead of having to wait until the next full reload of the page. There's also some, you can also set event listeners on this object and get some interesting status updates about what's going on. There's this checking, which is again fetching the manifest for the first time or to see if there's a new update. There's downloading, which is fetching all the resources listed in that manifest. There's also some progress events that you can get as those downloads progress. So you could potentially even have like a loading bar to tell people when they're ready to go offline. And then there's some sort of final state events, and this is when the app cache has done attempting to update or load for the first time and has reached some final conclusion about state. So there's no update, which is pretty self-explanatory. There's cached, which means that this is an initial load and all the resources were fetched successfully. There's update ready, which is similar to the update ready state. And obsolete, again, is similar to the obsolete state. And then there's the error event, which can be kind of a terminating state. Yes, it's always a terminating state, but can signal a variety of things. Like the manifest might be gone, or fetching one of the resources might have failed, or there might have been a parsing error, or a bunch of different things. Okay, so that's the bulk of my main content. Any other, questions? Yes. So I'd like to.
We have
someone on VC. Yes.
Yeah. Oh, okay. The question is, how commonly used are these application caches right now in terms of non-Google applications, as well as are any Google applications using it soon or already?
Okay, so currently these are used by some of the Chrome Store web applications, like the Poppet thing that they demoed at the launch event. That uses an application cache to make itself available offline. And I believe that some of our mobile products are using it, although I can't recall exactly which ones, but it's definitely a small number, and this is all very new. Yeah.
Question. I'm kind of naive about HTML5. If I was writing a email client or a bulletin board client and I wanted to save like 1,000 recent messages so that I can edit them on an airplane, does this work for that? And how do you structure it?
Okay, so the answer is no, this really does not cover that because that's like dynamic user type data. This only handles static, relatively unchanging resources, such as like CSS sprites and style sheets. For messages or other sorts of dynamic information, let's say high scores or something like that, you would need to use one of the other storage specifications. There's web storage, which is a basic like key value pair of strings. And there's WebSQL, which basically provides access to an SQLite database, but it's non-standard, but does exist. Unlike IndexedDB, which is only just now appearing in the latest versions of Chrome, but is actually standards track. So you would need to use one of those.
I have another question. I'm from advertising, and so I'm going to ask this question. If somebody is writing an application, and today we serve ads either inline in the DOM or in an iframe, if the manifest itself does not include like the wildcard, and since most ads are served from a different domain, would that cause problems, or it won't cause problems for us?
That would potentially cause problems, yes.
Okay. So that means that we would have to proactively, at least from the advertising side, be aware of folks that might be using this and actually come up with guidelines to say that if you want to preserve your ads, then from like AdSense, for instance, then you would have to code your manifest in a certain way.
Yes, I'd also argue that there's another like general design question of whether or not you want to make ads available when the user is offline in a way similar to like most, say Android applications display ads when they're offline. But yeah, as even a basic thing, if you want online ads to work, they have to include that wildcard, or they could include if it's like a one domain or a small set of domains that they could potentially include in their whitelist section of their manifest, they could do that.
Well, typically, I guess with third-party ad serving, we really don't know whose ads we end up serving. So it would be very difficult to pre-specify what domains they come from.
Right.
Yeah. Thanks.
Sure. Okay. You have a question. Okay. He made the point that advertisers would expect their ads to be clicked. And again, this is like you'd have to use one of the other storage technologies to keep track of all that and have some sort of system for getting these changes back to the server so they're persisted there. Right. Yeah. Yeah. So just summarize that comment. If you're using application caches at all for your page and it gets associated as part of the top level navigation, then you need to have that asterisk wildcard, or ads will fail miserably. Yes. Right. Okay, so the question was about how do you actually figure out what the heck to put in the manifest with a sizable application, and my general recommendation for that is to have some sort of registry. If you're already presumably, like when you're pushing updates to your application to a server, you already have to enumerate those resources somehow. hopefully you can leverage that same process to make sure that you still, to also provide the entries for your manifest, along with like any hacks that you want to do to make sure that the manifest has some sort of byte level change in it when one of the resources mentioned by it changes. How you do this will, of course, depend on how your application is designed. Like you might have like a registry thing. You might just, do a find command on the command line, something like that. Or Juice has Juice multi-binders are really helpful in Java land. You're using Juice. Okay.
Question on. I'm sorry.
Yes, go ahead.
I have a question on the size of the application cache. Like, is there what is the typical size per? Is it by domain, and is it bigger on like desktops than mobile devices?
So I don't know about desktop versus mobile devices. I haven't done a lot of testing of the limits with mobile devices. I know that on desktops, the typical limit that you can expect is 5 megabytes per cache. And that is actually potentially smaller if while it's updating, if the updated resources count against your quota, then you effectively have like a 2.5 megabyte limit. So it's relatively, well, it depends on the scale of your application, basically. If you're dealing with like a typical Google application, then we're easily into megabytes. And if you're dealing with something relatively straightforward that just has jQuery, then it's not an issue. But it's definitely something you need to think about. There's a larger problem with HTML5 APIs and quota and being able to inspect that quota and request more quota. Right now, there isn't a terribly good answer for it, but there are people working on it. My current recommended workaround for things that are like Chrome apps is you can include an unlimited storage permission, and that will let you shove as much stuff as you want in there. You still should have some way to keep it from growing unbounded, though. So the issue where HTML pages implicitly are added as entries to an app cache is actually an issue for that storage management, because if you include like an ID of some sort that there's a lot of, like if you're doing like email and you include an ID for every email message and you're caching like an entire copy of Gmail for every single email message, then that gets quite large pretty quickly. Okay.
So I have a question.
Yes.
Hello? Yes, please. This is regarding the cross-domain versus same origin. You mentioned we can only use this cache if all the resources are fetched from the same origin, right? Is there a plan for supporting cross-domain?
So about cross-domain support, if you're on just HTTP, you're not using SSL or TLS, then the resources in an app cache can be from across many different origins. The app cache must still be on the same origin as the web page referring to it.
Okay.
So, Google, like foo.example.com cannot have a manifest on bar.example.com. Okay. The manifest must be on the same origin. If you are on HTTPS with SSL and TLS, then you just have to somehow get everything under the same domain currently. I'm not aware of any proposed workarounds for that. The restriction was put in place for these secure sites as a security concern. You probably need to take up with Ian Hickson.
If those domains support options request, the security should be addressed, right? Because the options request is what that actually addresses the security problem, as I understand.
Yeah, I mean, this is a larger design discussion about how we want to solve this. issue, but there's definitely ways that we could reasonably add, like support could be added to the specification for it, I think, in my opinion. But yeah. Okay. Any more questions? Okay, so the question is, does it make sense to have multiple cache manifests on a single domain? My response to that would be that you probably want to keep the number of manifests small, just because if you have a large number of manifests, and particularly with the way cache selection occurs for top-level browsing, it would be very easy to have things happen in a bad way where like a fallback entry matches something that's like in an iframe on a different page under your same domain. But right, yeah, I think there's definitely good use cases, like having multiple applications under different paths with like completely different prefixes. I think you could do that reasonably with multiple application caches. Yeah.
I have a question.
Any more questions? Yes.
Yeah. How is it supposed to interact with regular HTTP browser HTTP caching, or is it supposed to be a replacement for it?
It completely subsumes it.
Okay.
Okay. Okay. Yeah.
Generally, it's designed to be a replacement for
Yeah. Okay. So I don't know if you could hear DBK, but
no.
Okay.
Could you repeat
So
it?
he was saying that when the browser is fetching all the resources in a manifest, then the browser's cache actually sits between the application cache and the server. So it would still pull from the local manifest, and
So, like,
there might
time to
also
live
be
stuff,
issues with
but-
proxies. Actually, proxy issues is part of the reason for no redirects, I think, or at least part of the motivation is because there's all these, you go onto untrusted Wi-Fi network, and a lot of times you get redirected to a sign-in page, and you really don't want that cached as like your style sheet. That would suck.
Next.
Okay. All right.
Question.
I'm sorry.
Yes.
A question here on the size and the management of the cache. Can a size limit be set? And in that case, what would be the replacement policy in the cache?
So right now, browsers seem to be running with a fixed limit for fixed per cache limit, and there's no way to request more or less space. And there's no way to, as an application, for you to explicitly expire those. As a user, some of them have UIs that let you view the manifest and actually remove it. Like, I think both Firefox and Chrome have reasonable integration with their like clear all sites data functionality. And I know at least in Chrome, there's the AppCache internals page. That shows your different manifests and how much space they're using, and you can delete them. But as an application, there's nothing right now, unfortunately.
I have a question on like the programming model for like applications running the app cache. I was confused by an earlier statement that says when you say that if you're using a fallback resource, then the URL may change or the referral URL may change. So does any JavaScript have to be modified to run in this mode, or does the DOM look any different, and so on?
So generally, the DOM does not look any different. The exception to this is the location property of the window, which, if you are the resource that has a fallback prefix associated with it, and like something matching that prefix fails, then the location will be the location of whatever resource was attempting to be loaded. So it's really not all that different. Like if you had a 404 page, and you just served as part of the response body to in your 404 response, then it would have, it would still be displayed at whatever the URL the user requested was. So you'd have a similar problem. So I don't think it changes things all that much.
Does this work with a push state, pop state? I mean, if the user opens page, index.html, and the application pushes a state to a different URL, but the page is the same, and then the user refreshes.
That's an interesting question. I don't actually know how this interacts with push state, pop state. I don't think push state and pop state actually trigger new navigation events. So I don't think they would like trigger the cache association type stuff. But I haven't looked at the spec that carefully.
Another question is the page aware of if the main page, is it aware if it's loaded from cache or from the network?
The page can interrogate that application cache object and check the state. And if the state is one of a number, I think there's a obsolete and uncached state are the two states where it is no longer associated with an application cache. But there is a way for you to check.
I have a question on the recommendation on the manifest. Let's say your application is AJAXy and somehow you can go into use, let's say 100 different images, but we don't have to put all of them in the cache. We can just put the most commonly used ones there, right? And let the less commonly used one be fetched from the network. Is that like a recommended paradigm if you expect it to be online all the time? And if you want to support offline mode, then you have to list all of them or have a fallback for some of them?
So your options are basically to list them in the manifest, not list them in the manifest, but have some network whitelist prefix or use the wildcard so that they are still fetched from the network. Or you can use some alternative technology like the file API that's new and just getting implemented in Chrome, which lets you actually XML HTTP request objects now have a response blob associated with them, property, and you can actually store that and get a URL back for it and stuff. But yeah. Okay. All right. That seems to be it on questions, and we're about out of time. With my whopping minute left, I'd like to thank a few people. And this is just in last name alphabetical order because I was wimpy and didn't feel like ranking. So David Barrett Kahn has been working with me on a project here and has been very helpful in asking questions and sorting this out and puzzling over things. Ian Hickson is the editor of the specification and therefore plays a very large role in what actually gets written online. If you want a change made, then you should bring it up with the appropriate working group, with the HTML5 working group, and he's the one who actually puts the appropriate official wording down. Michael Nordman is responsible for the WebKit implementation, which is used in 4 of the browsers that actually support this: Chrome, Safari, Android, and the iPhone browser. And he's been tremendously helpful with answering questions, and he also fixed the bug that I mentioned very, very quickly. I reported it, and it was fixed a week later, which is awesome. And Google has invested heavily in all of this, so I have to thank Google. And thank you all for coming and listening to this talk and asking such great questions.
Thank you.